Hello everyone. Today I am here to discuss two-component system in the phase rule. After studying this lecture, you shall be able to know about the concept of eutectic system, know about the basic concept of eutectic mixture and eutectic point, and understand two-component system in the phase rule diagram. Now, let us discuss two-component system. According to the phase rule equation, F is equals to C minus P plus 2, where F is the degree of freedom, C is the component, P is the phase. If C is equals to 2, then the value of F is equals to 4 minus P. For a system with two component and one phase, then the degree of freedom will be 3, which can be easily shown by the phase rule equation. That is, F is equals to 4 minus 1, which is equals to 3. Therefore, three variables would be necessary to describe a system. That is, temperature, pressure, and composition. All these variables are required, therefore, a three-dimensional model required for the presentation, which is more complex and difficult to understand. We have 2D planes and therefore we consider one variable as constant. Only two variables are considered. This reduces the degree of freedom of the equilibrium system, and the phase rule is written as F is equals to C minus P plus 1. This is known as reduced or condensed phase rule. In general, most of the experiments are conducted in the open vessel where pressure is constant. So, we generally express phase diagram of two components by using variable temperature and composition. Now, what is eutectic system? Eutectic system is a binary system consisting of two substances that are miscible in all proportions in the liquid, that is, solution phase, without reacting chemically. Generally, eutectic means easy to melt. For example, bismuth cadmium, lead silver, Ki water systems, etc. Now, let us discuss eutectic mixture and eutectic point. Eutectic mixture is a solid solution of two or more substances having the lowest freezing point of all the possible mixtures of the components. This is taken advantage of an alloy of low melting point, which is generally eutectic mixture. Two or more substances capable of forming solid solution with each other have the property of lowering each other's freezing point, and the minimum freezing point attainable corresponding to the eutectic mixture is termed as eutectic point. For example, in lead silver system, eutectic point is achieved when the composition is 97.4% and 2.6% of silver. Now, let us discuss the characteristics of the eutectic point. Eutectic point represents the lowest or limiting temperature at which the liquid phase can exist in the system, or it is a minimum temperature up to which a solid phase can exist. Systems giving rise to the eutectic point are known as eutectic systems. No other mixture containing the two components will have a melting point lower than the eutectic temperature. Now, let us consider the example of the two-component system, that is lead-silver system. It is a two-component system. Both lead and silver are completely miscible in liquid state and form a homogeneous mixture without formation of any compound by mixing of lead and silver. Melting point of the pure lead and silver are 327 degrees Celsius and 961 degrees Celsius respectively. Melting point of both components, that is solvent, is lowered by the addition of the solute. On addition of the silver in the lead, melting point of the lead is lowered and vice versa. The phase diagram of the lead-silver system consists of the following points. Number 1, curve AO and BO. Areas above AOB, this one, below AO, this one, and below OB, this one. Eutectic point O. Now, let us discuss first curves. Curve AO. This curve represents the melting point or freezing point curve of lead by the small addition of the amount of silver. Along this curve, solid lead plus liquid metals are in equilibrium. Along this curve, the silver which are added goes into the solution while the separation of the solid lead takes place. So, the solid lead and liquid, that is the solution of Ag in liquid PV, are in equilibrium. So C is equals to 2 and P is equals to 2. According to the phase rule equation, F is equals to C minus P plus 1, which is equals to 2 minus 2 plus 1, that is 1, means system is univariate along this curve. So, to specify the condition of the equilibrium between two phases, only one variable, either temperature or composition, is to be specified. Now, let us consider the curve BO. This curve represents the melting point or freezing point curve of silver by the addition of small amount of lead. Along this curve, which is added goes into the solution while the separation of the solid silver takes place. Along this curve, two phases, solid silver and liquid metals, are in equilibrium. So, solid Ag and liquid, that is the solution of PV in liquid Ag, are in equilibrium. For that, C is equals to 2 and P is equals to 2. So according to the phase rule equation, that is F is equals to C minus P plus 1, which is equals to 2 minus 2 plus 1, that is 1, means system is univariate along this curve. S two-phase solid Ag and liquid metals are in equilibrium. Only one variable, either temperature or composition, is to be specified for specify the conditions of the equilibrium between two phases. Now, we discuss areas. Area above AOB, this one. In this area, only one phase, that is liquid melts, means the solution of silver and lead coexist. So according to the phase rule equation, F is equals to C minus P plus 1, which is equals to 2 minus 1 plus 1, that is 2, means system is bivariant in this region. So to show the existence of this phase in this region, two variables, temperature as well as composition, are required. Now, the second area below AO, or area enclosed between the AOC. In this area AOC, solid lead and liquid metals coexist. So according to phase rule equation, F is equals to C minus P plus 1, where the value of C is 2, P is 2 So we put these values in the equation, that is 2 minus 2 plus 1, which is equals to 1, means system is univariant in this region. Only one variable, either temperature or composition, is required to specify the equilibrium state. The third area below BO, or area enclosed between BOD. In this area, solid, silver and liquid melts coexist. So according to the condensed phase rule equation, F is equals to C minus P plus 1, where C is equals to 2, P is equals to 2. So we put the value in the phase rule equation and we get 1, means system is univariate. Next area below the line COD, this one. In this area enclosed between COEF, this area, solid PB and eutectic phase are coexist in this region. According to the phase rule equation, F is equals to C minus P plus 1, where C is equals to 2, P is equals to 2. So the degree of freedom is 1, means system is univariate. So the next area is area enclosed between O, D, G, E, that area. So solid, silver and eutectic phase are coexist in this region. So according to phase rule equation, F is equals to C minus P plus 1, that is 2 minus 2 plus 1, which is equals to 1, means system is univariate. Now, let us consider points, point A and point B. A represents the melting point of pure silver, that is 327 degrees Celsius, and the point B represents the melting point of pure silver, that is 961 degrees Celsius. So at point A, solid Pb and liquid Pb are in equilibrium. So for that, phase is equals to 2 and the number of component is equals to 1. So according to the phase rule equation, F is equals to C minus P plus 1. That is equals to 1 minus 2 plus 1 means 0. So the system is invariant. Now let us talk about the eutectic point O. It is a point where the two curves AO and BO meet. At this point, three phases are in equilibrium. That is, at point O, solid Ag means silver, solid Pb means lead, and liquid meet solution of Pb and Ag. So, according to the phase rule equation, C minus P plus 1 equals to 2 minus 3 plus 1, that is 0. Hence, the system is invariant. So, this point O represents the lowest possible temperature, that is 303 degrees Celsius, below which a liquid phase cannot exist and beyond which the liquid phase cannot be enriched in either component by freezing out the other component. Such type of the liquid mixture of lead and silver, which has a lowest freezing point corresponding to all the liquid mixtures, are called eutectic mixture, and the corresponding temperature is known as eutectic temperature. So at the eutectic point, lead equals to 97.4% and silver equals to 2.6%, and the eutectic temperature is equals to 303 degrees Celsius. So according to my presentation, these are the some practice questions like define the term eutectic mixture, explain the term eutectic points and eutectic system, explain the two component phase rule with suitable diagram, and discuss the significance of the two component system. These are the references which is used in our PPT. Thank you.